So now we are in last assignment, assignment 7. This is our second assignment on the topic hypothesis testing. So let's begin with the introduction given here. In this assignment, we will perform two sample tests using difference of proportion. The dataset contains record of baseball players. Two baseball players had their career records compared. In 267 times at bat, one player hit 85 home runs, and in 248 times at bat, the other player hit 89 home runs. Now assume the number of home runs follows a binomial distribution. So is there a statistically significant difference with 95% confidence between the home run averages for these two baseball players? So here we will use two sample tests. And since it is a problem of proportion, so we will be using two sample tests using difference of proportion. So let's start with our question 1. Question 1 says, use the above dataset and perform the following. Part A says, create a matrix with the data. Part B says, define a null hypothesis and alternate hypothesis. Part C says, perform a two-sided test on the proportions of home runs hit for each player. So let's start with part A. Here we will create a matrix. This matrix will have the percentage of home runs hit by the players. We will use matrix function, and as given in the question, out of 267 times at bat, player A hit 85 home runs, and out of 248 times at bat, player B has hit 89 home runs. And then we will mention percentages when these players did not hit the home run. After this, we will mention how many rows will be there. So 2 rows for 2 players will be there. And 2 columns, one for percentage of home runs hit and other for percentage of home runs did not hit. We will then name our rows and columns by using list command as shown here. And then we will store this matrix in a variable called b.vol and run this entire function. After this, we will print this matrix as shown here. So as you can see here, player A has hit home run in 32% of games and player B has hit home runs in 36% of games. Similarly, no home run hit by player A is 68% and for player B it is 64%. Now moving to part B, it says define a null and alternate hypothesis for this question. So our null hypothesis is that there is no difference in the two proportions. So it will be proportion 1 minus proportion 2 is equal to 0. And our alternate hypothesis is that there is a difference. So it will be proportion 1 minus proportion 2 is not equal to 0. Then we will move to part C. It says perform a two-sided test on the proportions of home runs hit for each player. So here we can use prop.test function. The first argument would be the matrix that has the proportions. Then in the alternative we will write two-sided and the confidence level is given as 95%. We can run this and our output will be printed as shown here. Now the output here returns the following. The chi-square test statistic. Recall in difference of proportion test, we calculated chi-square test statistic instead of t or z. Then p-value is given. Then 95% confidence interval is given. And then the probability of success is given that we had already calculated while creating the matrix. It is 32% and 36% respectively for player A and player B. Now whatever I have just explained, it is also given under the explanation as shown here. You can refer to it if you have any doubts. Now as p-value is greater than 0.05, our significance level, hence we do not reject the null hypothesis. And we can conclude that there is no statistically significant difference between the two proportions. Now moving to the next question, question 2. It says using the home prices.csv data, perform the following actions. Part A says read in the data and look at the structure of the data frame. Then part B, look at the summary stats for price across NBR segments. So NBR and price are two variables given in the data. We will look at it. Then part C, look at the summary stats for price across corner segments. Again, corner is another variable. Then part D says compare mean selling prices between homes located in the northeast sector of the city versus the homes located elsewhere in the city. And last part E says compare the mean selling prices between homes with a corner lot and those without a corner lot. So let's start with part A. First we will read the data as shown here, and then we will store it in a variable called home. After that we will check the structure of the data. So as we can see here in the output of the str function, there are 8 variables with 117 observations. We have price, area in square feet, year, etc. given here. Their classes are also given here, and so on. Now part B says find the summary based on NBR. So if you see NBR variable, it has 2 labels, yes or no. So we want to find the price summary here for each yes and for each no. So here we can use a function called by. We use by to carry out any operation on a particular variable based on a criteria. As you can see, the first variable here is price. The criteria is given as NBR. And what type of output we need? We need summary. We will run this and we will get the summary of prices based on NBR as shown here. So we have 2 levels of NBR as yes or no. Hence we got 2 summaries for price based on NBR category. Again, I have included the explanation for question B and C. You can refer to it if you have any confusion. Now moving to part C, which says home price summary is required based on corner. Now again, if you see, the variable corner has got 2 levels, no and yes. So you have to find the home price summary based on these 2 levels. Now in this question, we can club by with another function called with. With takes the first argument as data and second argument as an expression. Expression contains an unevaluated statement. For example, if we write x1 plus x2, it will be called as an expression. However, if we write sum, then it will be called as a function. So basically, x1 plus x2 is an expression which is not evaluated unless we provide a function. So if you see, in by function, we had to name each of the columns. So let's go back to the by function. And here you can see, we had to name each of the columns using the $sign. Now on the contrary, when we couple this with the with function, then we just pass the names in the by command, which is like an expression, and then has mentioned the data in the first argument of the with function. This makes data handling a lot easier, especially when there are multiple columns, etc. So this way we have learned 2 different functions. Now we will run this and we will get our output. You can see that we have got the summary of price across different corners. Again, the explanation for the function is given here. You can refer to it if you have any doubts. Now in the next question, it is asking us to compare mean selling price between homes with a corner lot and those without a corner lot. So here we can use by, or we can use with along with by function. So we will use by along with the with function. First argument here is again data. Then second would be the by function. So the first argument is price. Second is NBR. And third is mean. Like this, we will run this function and we will get mean selling price for homes located in northeast sector and the homes that are not located in the northeast sector. Similarly, in the next part, it is asking us to compare mean selling price between homes with a corner lot and those which do not have a corner lot. We can again use the with and by function here as well. So here in the by function, the first argument is the price and the second argument is corner. And the third argument will remain as mean. We will run this and we'll get our mean selling price for homes with a corner lot and for those which do not have a corner lot. Now moving to the next question, which is question 3. Here it says use tires data and perform the following actions. Part A says read the tires data and look at the structure and summary stats. Part B says visually inspect the data using a scatter plot. And part C says add an equality line to the plot. So first we will read the data as shown here and we will store it in a variable called tires. And then we will check the structure of our data. So as you can see, there are 16 observations with two variables, WGT and GRO. Then we can also check the summary of our data as shown here. Then moving to part B, which says visually inspect the data using a scatter plot. So here we will use the plot function and give our first variable GRO as first argument. Then color is red. X-axis will be named as X. Y-axis will be named as Y. Xlim is to control the limit of X-axis. We are using max of the two variables and dividing it by 2. It is up to us what limit we want our X-axis to be restricted. So you could use something else as well. CEX is to scale the symbols representing the data points. So basically how big or small symbols we need in proportion to graph. After this we will use points function. By using point function we will be able to add WGT variable over the same plot. So the first argument is WGT variable. And then we have color, which is green. Again CEX, which is basically the size of the symbols. And then PCH is equal to 11. PCH is basically used to add different symbols representing the data points. So we can mention any random value. It will automatically assign a symbol to it. After the point function, we will add legends to our graph. We will use legend function. In legend, we have mentioned where we need legends to be displayed. So we have mentioned top left here, because we want our legends on the top left as shown here. Then mention the legends, that is WGT and GRO. Then color of legends, red and green. Size of legends using PCH. And then inset. Inset basically shows the distance of legend box from the boundary of graph. So you can try different numbers and see where your legends are displaying in your graph. After this, we will run all these three functions and we'll get our graph as shown here. Again, I have included the explanation. You can refer to it if you have any doubts. Now the next part says add an equality line to the plot. So let's see how can we add an equality line in the graph. So we can use plot function and give our data tires as an input. Then to add an equality line, we will use segment function. In the segment function, we would need minimum and maximum of X and Y variables, which will be required to plot the line, as these will be its coordinates. So minimum of WGT and minimum of GRO and maximum WGT and maximum of GRO are mentioned here. Then LTY is for line type, which is basically plain, dash, dotted, etc. And LWD is the width of the line. So again, I have mentioned 2 and 3 just randomly. So you can try different numbers and see what suits you. After this, we will run this entire function and we will get our plot along with the equality line as shown here. Again, as you can see, explanation is given here. Now moving on to the next question, question 4. It says use a paired t-test at the 95% confidence level to test for a difference between the two methods. And then report your results using a confidence interval. Make sure to perform the general steps of an analysis. So first we will define our null and alternate hypothesis. So null hypothesis would be statistically significant difference is there in both measurement techniques. And alternate hypothesis would be statistically significant difference is not there in both measurement techniques. Now in part B, we will compute the paired t-test for the two variables with confidence level 95% and report results. So here we can use t.test function. We can give our two variables wgt and gro. Then mention alternate as two-sided because it is a two-sided test. Then confidence level is equal to 0.95. And then we'll also mention paired is equal to true. So we can run this and we will get our results. So we can see our output. We have our variables wgt and gro. Then we have t-value. Then degree of freedom, which is 15. Then we have our p-value. Then alternate hypothesis, which says true difference in mean is not equal to 0. Then our confidence level at 95%. And then our sample estimates. So here p-value is given as 4.61 into 10 raised to the power minus 5. So here we can see that p-value is less than alpha. Hence we reject the null hypothesis. And therefore it can be concluded that statistically significant difference is not there in both the measurement techniques. So with this we will wrap up this assignment. Let's quickly revise what we have learned so far. We have first created a matrix for baseball players and then carried out two sample proportion test. Then we learned two functions, namely by and the with function. We used home data to learn these two functions. And lastly, we carried out two sample t-tests for the tires dataset. So I really hope you have got some idea about R by now. Now in this section, we had covered basic arithmetic, wherein we performed some basic math operations in R. Then we delved deeper and learned to manipulate data by subsetting and performing basic mathematical operations on columns, etc. Then we learned loop structures such as for loop, while loop, and apply functions. After that, we did some basic analysis on stock price data, such as plotting the data, finding covariance, etc. And then we took another data set, concrete data, and again performed basic analysis such as exploring data, outlier detection, plotting, correlation plots, and so on. And then in the last two assignments, we defined null hypothesis and performed hypothesis testing. We also learned box plots and created confidence intervals. So that will be all from section 2. And I hope you have started gaining traction now and must be feeling excited after seeing things finally started falling in place. I mean how theoretical concepts are being implemented in R and how they are being interpreted. So with this, I would like to end the video here. So I'll see you guys in the next module where we will begin modeling. Until then, have a great time. See you.